This video is brought to you by makeITsimpleTT, the premier online learning space for CSEC IT and computer science classes in the Caribbean. All our classes are run on the familiar and secure Google Classroom platform. The weekly videos are well laid out and labeled by topic, dated, and placed in reverse chronological order to ensure easy access even if you miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. So today we're going to be doing selection control structures, and selection control structures is you asking a computer to make a decision. So here's how it goes. For any human being, a human being has to make a decision. So we're still going on we're still working with the analogy of the 3-year-old, right? So this 3-year-old, if you are giving a 3-year-old some instructions on what to do, you would want to tell the 3-year-old what to do and tell it what to do line by line. That's what you call sequential. So you go statement 1, statement 2, statement 3, and the 3-year-old will follow you and do whatever you said to do. But if you want the 3-year-old to make a decision, you have to now be able to program how the decision is going to be made. So here's what usually happens. Usually when people go through a line, sometimes they meet a fork in the road. And that fork in the road will carry you to option 1 or option 2. And the same thing applies to a computer. We're trying to get computers to be able to make a decision based on our instructions. So we tell the computer, okay, do all of these things here, do this line, do that line, do that line, do that line. When you reach here, you have to decide what direction you're going to go based on some choice or some question that you're going to ask here. So what you're doing with an if then else is you're creating a way for the computer, or in our case the analogy is a 3-year-old, to make the correct choice on which direction they're going to go. So different instructions are based on if a set condition is true or false. Now condition is a key word because condition is what you are going to use to determine whether or not you make a particular decision. And that comes in the form of if then else. So you tell the child, go to the fridge and get me a bottle of water. Right? Your instruction is clear. But you want to say, if the bottle of water is not cold, or if the bottle of water is lukewarm, or if the bottle of water is full or empty, do XYZ. So a simple example would be like, I'll say, child, go to the fridge and get me a bottle of water. If it is cold, bring it. Else, bring a cup with ice and the bottle. So I am giving the child the choice. Listen, this is what I want you to do. This is what I want you to choose. And then if the child doesn't follow your instructions, he'll just be like, what?
No! God, please, no! No! No!
But that doesn't happen to a computer. The child may not follow your instructions, but the computer will follow your instructions. And it's all based on a condition. So let's look at a condition very simply. We say, if rain is falling, right? If rain is falling. Now, rain is falling is a condition that we have to check. And if the rain is falling, there are two answers I could have. You could have yes, rain is falling, or no, rain is not falling. Now, we have to be able to take this yes and no and kind of align it with, okay, if the answer is yes, you do this option here. If the answer is no, you do this option here. So our choice is, if rain is falling, this is the condition. Everything hinges on the condition. Based on what the condition is, it's going to determine which instruction you choose. So the first instruction, stay inside, that's going to be chosen if your answer is yes. So yes, rain is falling, then choose this option. No, rain is not falling, then choose this option. Everything hinges on what is the status of the condition. The status of the condition could be any condition that you want that a computer will be able to understand. So when we're giving our computer instructions, we have to be able to give the conditions based on how they understand things. And if you watch the previous videos to let you know that computers understand variables and logic. So equal to, less than or equal to, greater than, less than, all that stuff. That is what a computer understands, and that is what a computer loves to see. So we have to be able to give the conditions based on how a computer will grasp it, not how a human will grasp it. Because if we give it how a human will grasp it, the computer will say, and you are? I don't know who you are. Because computers are like that, right? Okay. Why is my head at the moment chakra to the left a little bit? Right, here. I'm in the correct position. Okay, so let's look at how a computer will see this question, see this decision. Let's say I want to get a computer to find the larger of two numbers. Now watch this closely. I'm going to give sequential instructions first. Remember, sequential is step by step. So I give the sequential instructions, which is okay, enter first number. Who sees this? The human being that is using the program sees this. When I say read num into num1, what is going to happen is that the computer is going to create a box. I should put the box on the side here. Put the box on the side. The computer is going to create a box called num1. And then I say enter second number. The person is going to see this and then read num2. So what will happen is the computer is going to create a box for num1 and create a box for num2. Now the user of the program, remember, you are not the user of the program, you are the creator of the program, you are the one giving the instructions. So because you are the one giving the instructions, you're going to try to make sure that it's as clear as possible. So the user enters their first number. Let's say the person puts in a number of 7. And then the second number, they put in a number that is 2. So those two numbers come inside, and now we have to make a decision based on those two numbers. Now, under normal circumstances, I can look at the two numbers and be like, okay, 7 is greater than 2, so therefore 7 is the larger number. But I'm a human. Remember, I'm trying to give this instruction to a computer so that the computer will be able to carry it out. So I have to now create a condition. The condition here is if num1 is greater than num2. Now the answer to this decision could be yes or no. So put a question mark next to it if that helps you understand it easier. The question is num1 greater than num2? The computer does not know what is inside num1 or num2 at the start, but because we got the user to input the values inside there, the user puts in 7 and 2. It could be 7 and 21, it could be 19 and 12, it could be 18 and 6. Doesn't matter. What really matters is, did we give the computer the instructions on how to handle it? Because our algorithm is giving the computer the instructions on how to actually handle the decision. So we gave the instruction, alright, if num1 is greater than num2, the answer could be yes or no. And in this case, the answer is 7 is greater than 2. So the answer is yes. So the computer answers the question and be like, okay, yes. Because the answer is yes, we choose the first set of options, which is yes here. This will print out the larger number is num1. So it'll print out the larger number is num1. But instead of putting the actual words num1, it will put whatever is inside num1. So that means you'll get 7 being printed out. And is it true that 7 is greater than 2? Yes. So that means this will be printed out, this one will be ignored, and our algorithm works. Now, how do we check to see if it actually works the other way around? So instead of putting the 7 and the 2 there, I put 2 here and I put 7 there. What will happen is, the computer is going to now say, okay, is num1 greater than num2? So the question is 2 greater than 7? And the answer is no, it is not. So because no is the answer, then this one will be chosen. The no one will always be the second one. And then you will now ignore the first one because the answer is not yes, and the answer is no. So therefore the larger number is num2. So we'll print out the larger number is num2, which is 7. So we've proven that this works. And it's a list of instructions that we give to the computer, and now the computer has the ability to make a decision because we created something called a condition. And we do things based on conditions all the time. That's like, you know, your mother tell you to clean up your room, and she say, you're not going anywhere unless you clean up your room. So the condition is if room is clean, then you get to go out, else you don't go anywhere. So that condition thing, that's literally wired into us as humans, and to represent it in our computer, it's simple to do this. Now, once you can get a computer to make decisions, then you have more possibilities of the things that you could do. Because sequential control structures, they just go one after the other, and there's no big set of options of what you can and cannot do. It just follows a line. But once you bring selection into place, you can have multiple ways of selecting different things. So let's watch this one. So this next example, write a pseudocode algorithm to accept the price of two computers and choose the lowest price. So I'm writing it so that the computer will be able to get the two numbers and choose the lowest price based on whatever number the person puts in. So I put start, enter the first price. What happens? Computer creates a box called P1. Then we have enter second price. What happens? Computer creates a box called P2. Whatever the user puts in doesn't matter to us, because remember, we are writing a solution to the problem. We're not actually trying to find the highest price for them. We're trying to get the computer to do that for us. So we give these instructions, the computer reads the two of them, and what happens is, let's say we have price 1, which is $10, and price 2, which is $12. Cool, great, wonderful. So now we say if P1 is less than P2, this here is called the condition. And because it's called the condition, we could put a question mark next to it because it's asking a question. We ask the question, is price 1 less than price 2? If the answer is yes, then we choose this one. If the answer is no, then we choose this one. Do we know the answer? Well, price 1 is 10 and price 2 is 12. So is price 1 less than price 2? The answer is no. Now remember, a computer loves numbers. So we get price 1 as a number, we get price 2 as a number, and it loves logic, which is less than, greater than equal to, less than, or just normal equal to. That's how our computer loves to make decisions. So when it's making the decisions, you say price 1 is less than price 2, and you're like, yeah, 10 is not less than 12. So the answer is no, so we're going to choose this. But notice, we have a new variable here called low. We didn't take that into consideration before. So in this case now, we're going to put LOW, low. So this is literally saying, if price 1 is less than price 2, take the 10 from price 1 and put it inside low if the answer is yes. Or take the 12 and put it inside low if the answer is no. So is price 1 less than price 2? The answer is yes. So we're going to choose this option here, and it will take price 1 and put it inside low, which will put the 10 right there. And once that 10 goes inside, then now low has 10. So this if statement here is done, because this if just makes a decision based on the condition. And once that's done, we can display low, and low will display exactly what's inside there. So instead of seeing low, we'll actually see 10 coming out on the screen. This video is brought to you by makeITsimpleTT. In every CSEC IT class, assignments are given on a weekly basis covering the topic that was taught in the class. The assignments are original questions and test the entire syllabus and model the style of questions that come in past papers. Monthly reports are also sent to parents and guardians, showing the progress of students. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. Alright, so those are two examples of a selection control structure. We're going to select between two possible options. So I'm going to do two starter questions, just for you all to understand. So this one is write a structured algorithm to prompt the user to input the mark of a student received in a test. If the mark is less than 6, the output will fail, or otherwise output will pass. So let's open up trusty old Notepad++. Oh, I've been doing all the questions. Yeah. Alright, so algorithm to determine pass or fail, right? So that should be or fail. Right, so I'll name it that. You know, they like to point out typos. Like whenever a teacher makes a spelling error, you will be quick to say, oh, so you spelled that wrong. And when the teacher asks, okay, so can anybody tell me what this means on the screen? And everybody will just be dead quiet because pointing out easy mistakes is what students love to do. But anyhow, algorithm to determine pass or fail. So variables, the variables that we need here would be mark. So I'll write out the whole word for mark. Normally I'll put the letter M. You could just put the letter M for mark. That's a lot easier for people to understand. So I'll just leave M. Start. So what I want to do is I want to ask the user to put in a value. So I'm going to put print. Please enter the mark the student got. And then you go read M, right? Because what I want to do is I want to read the M, read the mark that the student got, right? My next thing now is I have to teach the computer, I have to tell the computer, okay, this is how you figure out if somebody passes or fails. Here's how you figure it out. You go if M is greater than, according to the question, it said 60. If M is greater than 60, then. So this here is called the condition. The condition is what is going to be checked to determine if you are yes or no. The condition is what is going to determine if you are going to make whatever choice. So if M is greater than 60, then I will want to print you have passed. So that will be the yes, right? If the M happens to go over 60, then it will automatically print you have passed. Else, print, because we're in 2021 and everybody is sensitive, you failed to pass. This time, kiddo, it's okay. Because, you know, children sensitive and you can't really tell a child you failed. That might scar them for life in 2021. Yeah, so let me just go back and say, yeah, you failed, right? Now, we have a problem here. The thing is, the pass mark is 60. So that means 60 counts as a pass mark. So your condition can't just be a simple greater than or less than. You have to consider that 60 is an acceptable number to pass. So there are two ways you could solve this problem. You could put M is greater than 59. That means once you cross 59, meaning you got 60, then that means you have passed. So M greater than 59 means, yeah, you get 60 and up. So that's one way to solve it. But then there are some people who like to do the greater than or equal to, which confuses some people sometimes. And I know for a fact that some students will get confused with greater than or equal to. What does that mean? That don't make sense. How you could be greater than or equal to? Wouldn't the computer get confused? Because I get confused. Well, the computer won't get confused because greater than or equal to is a valid way of writing a condition. But if this one confuses you because you don't really grasp what greater than or equal to is, just take the number that they told you and take away one from it and say, okay, cool. If 60 is the pass mark, that means to pass you have to get more than 59. So either way, greater than or equal to 60 or greater than 59, which one suits you, you could do. I personally rather put greater than or equal to 60 because it just feels better for me. But some of you won't find it feels better. And then at the end of it all, I will print stop. So what the computer does, line by line, is this. It says, okay, computer, start, print, please enter the mark the student got. So this is what the human being is going to do. The human being is going to put in the mark that they got, which is M. When M comes in, we don't know what M is, but we know what M is supposed to be in order to pass or fail. So if M is greater than or equal to 60, that means we know that the person passed. Regardless if it's 61, 60, 89, 99 or whatever, we know that M is that. If it's not over 60, then we print you have failed. And that is a simple selection algorithm. All right, so let me do one more example before we call it a day. All right, so let's say we wanted to find ask the user to input three numbers, and based on the three numbers we determine if their average is a pass or fail average, right? So let's do that. Control and N. So I'm going to put the name. This is question ask a user to put in three numbers, find the average, and determine if they pass or fail the pass mark is 50. All right, so that's the question. So we're going to start by algorithm. We'll name it pass or fail. Pass or fail. And then we will go to the variables. So the variables I need here would be three variables. I need variables. There are three marks, right? So I'll put M1, M2, and M3. Mark 1, Mark 2, and Mark 3. And then I have average. The reason I'm putting in average is because those are the things that I need to calculate. So based on the fact that I got Mark 1, Mark 2, and Mark 3, how do I now find the average of that and see if they pass or fail? So I have to tell the computer to start. Why do I tell the computer to start? Because it's important that you give every single instruction that the computer needs, or else it won't follow the instructions properly, just like I told you all with the 3-year-old, right? If you don't give the 3-year-old the instructions very clearly, 3-year-old will mess it up. So I'm going to start. I'm going to print, enter your 3 marks, and then I read M1, M2, M3. So I get those 3 marks, and now my goal is now to say, okay, read M1, M2, M3. What do I want to do? I want to now calculate the average and say average is equal to M1 plus M2 plus M3 all divided by 3, right? If you don't understand how to do that, go back to the previous video and you will see sequential, how to do sequential, because all of this is sequential. So now that I've found the average, I want to now check to see if the average is greater than 50. So I'm going to say average is, if average is greater than 50. But remember, we have the problem where if you get 50, it's supposed to pass also. So you have to put greater than or equal to 50, because that will now cover if somebody has 50 on the dot. If average is greater than 50, then I'll print you have passed. Else, I'll print you did not pass. End if. And then I print stop. And that is my selection algorithm there. That literally solves the problem of ask a user to put in 3 numbers and find the average. Did we do that? Yes, we did that at the start. Determine if they pass or fail. The pass mark is 50. So I get the 3 numbers, M1, M2, M3. I determine if they pass or fail, M1, M2, M3 divided by 3. And then I check to see if the average is greater than 50, then print you have passed, else print you did not pass. Or you could print you have failed. And that's a simple selection. It doesn't get much harder than that. This question was actually, I think, a past paper question from the 2021, the July 2021 paper. This was the question that they asked you for 10 marks. Now they can ask you a very, very complicated like loop questions if they want to, or they could ask you questions like this and you get a whole 10 marks. And it's really not that hard. But they could also ask you deeper stuff, which is loops. So we'll be doing loops in the next video. This video is brought to you by makeITsimpleTT. Every class is structured to run on a yearly cycle from June to May. This cycle covers the whole syllabus in 12 months with 1 2-hour session per week, along with assignments that are given weekly. Every class is recorded so students can always go over the work and recap notes in case they miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799.